Welcome to Maths and Science Unpacked. I'm very delighted to have you here. We are beginning a new series of videos where we explore the major topic, algebra. Algebra is a very interesting subject in maths. It has a very interesting history that I want to share a bit with you. Did you know that humans have been doing algebra for over 4,000 years? Yes. Algebra was done in ancient civilizations like Babylon and Egypt around 2000 BCE. And the word algebra is actually an Arabic word. It came from the Arabic language. The word itself is al-jabr, and it means reunion of broken parts. So what we are actually doing today in algebra is very relevant to what our ancient forebears did, trying to reunite broken parts. You'll soon realize that when we go to solving algebra, we usually present with many broken parts, some represented by alphabets, some represented by numbers, and the objective is always to reunite them to make a sense out of it. And that is what algebra has been about for over 4,000 years that humans have started tinkering with algebra. So let's go and look at some of the exciting topics in algebra. Join me on the whiteboard. Thank you. So welcome to another episode of Maths Lessons. As I introduced earlier on, we are looking at algebra. Now, for those of us in secondary school or high school, algebra is really a very major and important topic. You will realize that in many general maths assessments, algebra is usually the most represented topic. Okay, so out of the 6 major topics, you can have algebra alone forming about 30% of a math paper. So when we do algebra and do it very well, we already have an upper hand. We are already about 30% ahead of the pack. And so I want you to really pay attention, look at all the videos that we'll be doing for algebra, and make sure that you have really understood the underlying concepts of algebra. Today's topic, I want to do something that is very, very important. We want to look at the subject-specific terminologies of algebra. Now, someone will wonder, we came here to do maths. Why are we bothering looking at words and meanings? It is very important. Now, if you have already done some revision through maths questions, you realize that many of the maths questions come with subject-specific terminology. And the examiner expects you to understand the meaning of the terms that are used in the questions. Sometimes we are fortunate. The terms that appear in maths questions are also the same as we find in everyday language, in everyday English. Other times, you really need to know the meaning of the term. So, in the first part of the lesson, I want us to spend about 5 to 10 minutes exploring the key terms in algebra. The key terms in algebra. So, let's look at them. The first thing that you would want to know about in algebra, which is a very important thing, is a variable. Okay? What is a variable? As the name suggests, in everyday English, a variable is something that varies. So in algebra, we start by having unknowns. There are certain things in an algebra question or an algebraic statement that we do not know. we represent them with variables. Variables will typically be represented by alphabets. So you can have A, B, C, and so on. They are all variables. They do not have one specific value. They represent a value that we do not know yet, that we are trying to uncover. Now, let me give you a question. Who can tell me the most commonly used letter in maths? Yes, the most commonly used letter in maths is X. And when we were in secondary school, we used to have a joke. We used to say that every day the maths teachers are asking us to find S. When will we find S at all? Every question, find S, find S, find S. But it's just a joke. S is usually the most commonly used variable, but there are others. You can use any letter at all to represent an unknown value in maths. The second terminology that I want us to be familiar with is constant. And again, we may know what a constant is. A constant is usually anything with a specific value. It has a specific value. Okay? So when I say 2, 2 is a constant, and 2 is 2. 2 will always be 2. Okay? Unlike variable, where A can represent 5 today, tomorrow A can represent -3, and so on. 2 will always be 2. So 2 is a constant. Okay? So far, so good. We know what a variable is. We know what a constant is. The next thing that we want to look at is a term. So what is a term? A term is very simple. It is a single number. A single number or constant, or a single variable, or a product of a constant and a variable. Okay, just take note of that. And I'm going to make some differentiations very soon. A term is a single number, a single constant, or a single variable, or a product of a variable and a constant. So let's look at something. 2 in algebra is a term. S is a term. This is a single number or a single constant. This is a single variable. Or a product of a constant and a variable. 2s is a term. 3y is a term. Or even a product of two different variables. Sy is a term, product. In maths, product simply means multiplication. So s times y is a term. Okay? 5sy is a term. So long as you have constants or variables joined together by multiplication, they remain a term. Okay? Now let's move on. Let's move on. We want to clear the space and continue. So far we know what a variable is. We know what a variable is. We know what a constant is. We have just looked at a term. The next thing in the hierarchy of terminologies in algebra is an expression. Okay? An expression is simple. If we have understood what a term is, then an expression is multiple terms or a number of terms joined by either an addition or subtraction. Okay. A number of terms. So we have already established that 2s is a term, 5y is a term, a single constant or a single variable, or two or more of them joined as a product, multiplying each other. Now, when we take each of the terms and we join them by a plus or a minus, that becomes an expression. So, for instance, 2s plus 5y is not a term, it is an expression. Why? Because we have multiple terms which are joined by a plus, or multiple terms which are joined by a subtraction. So that is an expression, okay? So we are building up the hierarchy. First, we start with a variable and a constant, then a term, okay? And then a term builds up to be an expression, okay? So from an expression, we go on to what we call an equation. Okay, an equation. In algebra, what is an equation? An equation builds upon an expression. An equation builds upon an expression. How? It is an expression that is equal to something. Okay, it can be anything. Okay, so first, this is an expression, 2s plus 5. That is an expression. The moment I establish that this is equal to something, it can be anything. Then once an expression is equal to something, that becomes an equation. That becomes an equation. Later on in the terminologies, we will see something that looks like an equation, but that is slightly different. And when we get there, I'll draw your mind to that. Okay, I'll draw your mind to that. Now, let's continue. So far, we have looked at a constant, a variable, they build up to a term builds up to an expression builds up to an equation. Okay, so far, so good. We've looked at 1, 2, 3, 4, 5. We've looked at 5 terms so far. Let's continue. The next thing that I want us to look at is called an identity. An identity. An identity is like an equation, but there is more to it. Okay, so what then is an identity? An identity is a kind of equation which is true for all values of a variable. And I'm going to unpack this in a minute. A kind of equation which is true for all values of a variable. So I can give an identity as this. 5n is equal to 2n plus 3n. Now, how do we distinguish between an identity and an equation? We use a 3-bar symbol, okay? So an identity usually have a 3-bar symbol. An equation only has a 2-bar symbol. So 2s plus 4 is equal to 10. This is an equation. This is an identity. And let me explain the difference between an equation and identity. We said an identity is a kind of equation, it's a special kind of equation which is true for all values of a variable. And in an equation is not true for all values of a variable. An identity is true for all values of a variable. So let's start and establish the difference. Here we have 2s plus 4 is equal to 10. This is an equation. It is only true, this equation is only true when s is equal to 3. Okay, so when s is equal to 3 and we plug s in here, we get 2 times 3, which is 6. 6 plus 4 is equal to 10. That is an equation. In an equation, the value of a variable is limited. It is only true for a specific value, an equation. When I decide that I want to try s is equal to 5, this equation will not be true. It is not an identity, therefore. So if I bring in 5, I'm going to get 2 times 5, which is 10, plus 4, which is 14, and not 10. So that is not true when s is 5. Okay? In an equation, the value of a variable is limited. It's often limited to a specific value. Now let's make our way to an identity. An identity is like a superstar equation. The value of the variable is true regardless of whatever number you put in. So let's try that. If I put 2 here, if I make n to be 2, then I have 10. And this will be 4. 2 times 2 is 4. 3 times 2 is 6. And that is true. Let's say tomorrow I decide that I want n to be 4. If I want n to be 4, it will still be true for the identity. Remember the definition of identity. A kind of equation which is true for all values of a variable. So any value at all you want to think for n, if it is an identity, it will be true. And that is the main difference between an identity and an equation. So now let me decide that n is 4. If n is 4, we have 5 times 4, which is 20, and is equal to 2 times 4, which is 8, plus 3 times 4, which is 12. And we have 20 being equal to 20, and it is true. So you see, we tried with n equals 2, and the identity was valid. We have just tried with 4, and the identity is valid. When I come and I try with any number, 234, 748, any number at all that I can think of n, if I input it in an identity, it will be true for that particular identity. So an identity is a kind of equation, but it's a special kind of equation which is true for all values of a variable. Okay, so that is the main difference between an identity. And remember that an identity will have a 3-bar symbol. An equation only have 2, but an identity will have a 3-bar symbol. So that is the main difference. So we are still building upon the story. After identity, what do we want to look at? After identity, what do we want to look at? We want to look at coefficient. What is coefficient in algebra? What is coefficient in algebra? Let me make way on a whiteboard and then we will look at what a coefficient is. A coefficient is simple and you will often come across this term in any math problem. So you need to understand what a coefficient is. A coefficient is simply the number, okay? The number that multiplies a variable in a term. So what do we mean? You remember when we were looking at terms, we said that it can be a product of a constant and a variable. The moment a constant comes to multiply a variable, that constant gets a special name, and that special name is a coefficient. So I have a constant 5. I have a variable s. The moment 5 comes to multiply s to give me 5s, the 5 in this term now has a special name, and that special name is a coefficient. And the reason why this is important is that a math question can be talking about a coefficient. And if you don't know when a constant becomes a coefficient, you could be at sea. You could be lost as to what the question is demanding. So it's very important that we are abreast with all these terms. What is the next thing that we want to look at? A formula. A formula. So earlier on in the lesson, I told you that we will come across another term that feels like an equation, and that is a formula. That is a formula. How can we distinguish between a formula and an equation? So let's look at what a formula is. A formula is a rule or a relationship, okay? And you will come across formulas in maths and in other subjects, especially science, okay? A formula is a rule or a relationship. Expressed using symbols. Okay, it is a kind of equation, but not strictly speaking an equation. In an equation, you normally have a term or an expression being equal to a specific value. So this will be a typical equation. 2s plus 5 is equal to 20. You have a term or an expression being equated to a specific value, okay, or another expression. How is a formula different? A formula is a rule or expression expressed using symbols, and in a formula, you may not necessarily have any constant value, okay? A very popular formula that we got from Einstein is E is equal to mc squared. It is a formula. It is used to calculate things like the speed of light and so on. When we go into physics, we will learn more about these things. It is a rule or a relationship between different quantities, okay? And there may not necessarily be a constant in that, but it still uses the equal to sign. And that is why a formula is a kind of equation. But it's a special kind of equation. And it can be presented just in symbols without any number. For instance, A is equal to B plus C. That is a formula. And then if you are applying it to solving a particular question, you then have to find out what the value of A is, what the value of B is, and what the value of C is to make sense of the formula. So that is the difference between a formula and an equation. There are many more terms that we could be looking at, but the remaining terms are actually algebra subtopics, and so we'll be looking at them on their own.